Namaskar, my dear friends. Let us talk about a stepper motor driver solution. So in this, what we have done is we have used a device MAX22211 that is there from Maxim Integrated or analog devices. So analog devices has acquired Maxim Integrated. So this is a very new and very powerful IC for a stepper motor driver MAX22211. Okay. So what we have done is we have developed a standalone solution using this IC, and as well as we have the microcontroller section, and then we have the power supply section, everything together. So in one board you will be able to develop and you will be able to define your stepper motor driver. So let us quickly understand what are the things that we are going to do in this. So basically this is a stepper motor driver from analog devices or Maxim integrated that we have already seen. And as you can see from the data sheet, it can work up to 36 volt rating and can give you 3.8 amperes of rating. However, we have designed it for, let us say, like 12 volt or 15 volt or like 18 volt or even 24 volt. So these many voltages you can give as your input for your motor driver. And I have limited the current rating to 1.9 ampere. If you want, you can set the other one pin. I will tell you that will give you a rating of 3.8 ampere completely. All right. So if you talk about like various applications that it can be used for, so it is basically a stepper motor driver. So wherever stepper motors are used, there you can utilize like robotic arms or printers or tray elevators. So basically this is a printer, this is robotic arms. Okay, this is printer, this is robotic arms, this is a like a tray elevators kind of thing. We have cameras as well, like moving cameras. In medical devices, if you want, you can utilize it in syringe pumps. Basically this is used for drug delivery and all, so there you can use. So this is very like nice IC, and you can see a very simplified block diagram is given here, that this is my stepper motor driver IC. It is having a interface with microcontroller, okay, with few lines, and you have the output of two pairs of output that is needed for a stepper motor. So basically if you want, you can drive a brushed DC motor also. So for brush DC motor, you can drive two brush DC motor, like only one pair is needed for brush DC motor. So one pair by this one, and one in brush DC motor by this one, and one brush DC motor by this one. Otherwise, however, this particular design is going to be used for your stepper motor driver. And what we have done is we have two packages available. One is 28 pin package, one is 32 pin package. However, we have used 32 pin package because it has much better heat dissipation capability. However, the functionality and pin configuration and all those things are exactly same between these two packages. In this package, 4 pins are there extra, which is going to be not used pin. All right. So let us start with the circuit design that we have done. All right. So as you can see, we have the this particular stepper motor driver symbol. So this is the symbol that is arranged in such a fashion that we have VDD, CDRA, CDRA-B, iSense A, iSense B. We have enable pin of first channel, enable pin of second channel. Then we have input pin, PWM input pin for first channel, and similar to that input pin for second channel. So basically two input pin, two PWM here and two PWM here. Then this is the thing that I was telling you, like if you keep it low, then it will be 1.9 ampere. Okay. And if you pull it high, let us say my microcontroller will set it high, then it will become 3.8 ampere rating. So current limit can be done by this one. We have reference for channel A, reference for channel B. So those are set default values. We have exposed pad and analog ground. So those are grounded here. Now as you can see, we have decay mode setting. So decay mode setting, if you want, you can set it based on your requirement. Like if you want it to be a slow mode or mixed 30% fast and 70% slow, or mixed 60% fast, 40% slow, or it is fast. So basically what I have done is I have put it in such a fashion that it is mixed 60% fast and 40% slow. Okay. If you want, you can change the other settings by microcontroller pin that is also connected here. However, hardware wise it has been made as 1 0. So 1 0 is nothing but your third one. Okay, so basically it is a decay mode setting of 60% fast and 40% slow. Now coming back to the power supply side. So power supply side, what I have done is I have given you an option of one connector to be connected. So this is a terminal block connector which will be taking your main input like 12-volt input or maybe 18-volt input or 24-volt input. So any of these voltage inputs you can give. Otherwise, if you want, you can directly connect a adapter jack of, let us say, 12-volt or maybe a 15-volt. Okay. So for a very simple, like adapters that are coming these days, and they can give you the power supply requirement for this particular like motor driver. We have ample amount of like capacitors put here so that it will be giving you sufficient power capability for the input of this particular motor driver. We have charge pump capacitors, we have charge pump capacitor one more, and then this is the main important thing that is there, our requirement, which is out 1A, out 2A and out 1B, out 2B. So this is the terminal block that is going to get connected to your stepper motor driver. I have given 4 test points also for these 4 like outputs. If you want, you can have a look into that as well if it is needed. Let's come back to other parts of the circuit. So other parts of the circuit, you can see we have fault signal. So if there is a fault, what will happen is it will go low. Okay. It means if there will be a fault observation, in that case it will become low, and this is how my LED will start glowing. Okay. Similar to that, if it is not in faulty condition, no problem is there, then it will be high and it means LED will be not glowing. So if it is not glowing, there is no fault. That you have to understand. Similar to that, iSense A, iSense B, sleep, all these things are pulled low based on requirement of the datasheet. By default, my enable A, enable B all are enabled. If you want, you can disable them. Similar to that, we have CDRA pin, CDRB pin. And if you see the like a PWM settings, so PWM settings has been done in such a fashion that it will be moving into your forward direction mode. Okay. So this was all about this particular like a motor driver circuit from the design point of view. Coming back to the interface with the microcontroller, so as you can see, interface with the microcontroller is here. So in that case, this is the microcontroller that has been used, very popular microcontroller, and like newly launched from Texas Instruments, that is MSP M0L series. Okay, so I have used 1306 part, which is having 32 pin VQFN, and this is very low cost device. So that's the reason like I have preferred this one. However, we have 4 PWMs for the utilization of this particular like stepper motor driver, and 2 external PWM I have given for some other usage if you want to have. Even I have I2C, so I2C can be used for some other purpose. Even we have UART, so UART also you can use for some other purpose. For that, I have provided one external like a connector here. So you can see external connector is there, which is having all the informations like I2C, PWMs, we have UART, and 2 external pins like PB0 and LED0, that is there from one of these PB LED0 and PB0. Okay, so 2 extra push buttons and 2 extra LEDs has been given, that also can be used for some like a status configuration or some status indication. Okay. Coming back to this particular microcontroller circuit design, so we have a reset circuit. So reset switch is given here. So if you want, you can reset this particular microcontroller very easily. This is the power supply pin. We have exposed pad. So thermal pad is there, which is pin number 33. I have put it. Okay. Then we have programming connector using SWD programming, like by wire programming. Only 2 wires will be required to program this particular microcontroller. And all other parts like decay mode setting using this. Then we have iSense A, iSense B, and then we have CDRA, CDRA B. Okay, so here we have little bit of this thing, you just remove this. Okay, that's all. And if you want to make your motor driver to go to sleep, this is the one of the output pin that has been used for making the motor driver into sleep mode. Alright, so hope you have now a clear idea about this particular microcontroller interfacing and this complete circuit design of a stepper motor driver. Okay. Now let's get back to the power supply requirement, because we know like a VDD is needed, which is my 3.3 volt. So 3.3 volt is needed somehow. So what I have done is the same power supply, which is VM. So VM can be like as high as, let us say, 24 volt or even 30 volt. So in that case I need to have some regulator which can withstand that value. So for that purpose, what I have done is I have used one regulator, 500 milliamperes output rating with this is the VM that is going to go into this particular like a linear regulator, and the very simple linear regulator which is going to give you VCC, that is your 5 volt. This has been protected with 5 volt as well, so that like you don't have to worry about it. Now a very simple 3.3 volt regulator that I have used for a 300 milliamperes rating. So 300 milliamperes is more than enough to run my microcontroller. And then VCC is going to get converted to 3V3. Okay. One more advantage that is there with this particular circuit is this VCC has been taken out with the external like pin, so that you can utilize your 5 volt. This 5 volt generated output can be utilized for some other functionality. All right. Good guys, so hope you have now a clear idea about this particular like motor driver circuit design, and we have the BOM and schematic design files and everything is available with us. So if you wish to have like if you wish to have this, or you want to explore the idea of stepper motor driver solutions, then you can always put down your question in the comment box and we shall be able to reach you out. Thank you.